Hello, welcome everyone to our joint online demonstration today with coolLED. I am Olivier, Sales Manager at INSCOPER. In a few minutes, we will join my colleague Julien at the microscope. Before meeting him, Joe Winston from coolLED and I will present some introductory slides. During the whole presentation, feel free to write your questions in the chat. We will answer them after the demo. So last year at INSCOPER, we were preparing this new commercial solution for ratiometric imaging when coolLED launched a new illumination source on the market. And this new pE-800 fura is perfectly suited for the probes used for calcium imaging. This is why we decided to test these two new products together and represent the results to you today. The acquisition you will see was performed on a microscope at the Microscopy facility of the University of Nantes, France, which also prepared the live samples for us. I would like to deeply thank them for their welcome and support. To start this presentation, a few words about ratiometric imaging. Ratiometric fluorescence is an imaging method where intensities at two or more wavelengths of an excitation or emission spectrum are measured to detect changes in the environment. Ratiometric imaging is used to measure pH changes, ion concentration, protein-protein interaction with threat. Conventional fluorescence markers used for non-ratiometric imaging methods do not take into account that differences in structure, diameter, or marker uptake can cause changes in the quantity of emitted light that are not in correlation with the ion concentration or pH. This is the advantage of ratiometric imaging to enable reproducible measurement of absolute intracellular ion and pH changes with respect to cell diameter, fluorophore concentration, and optical properties of the imaging setup. Now let's introduce the liveRATIO solution. So liveRATIO is a turnkey solution for calcium, threat, and ratiometric imaging. As you can see on the scheme, it consists of an electronic box called device controller that controls the microscope and all its devices, and a graphical user interface to set up the acquisition sequences and process the images. In this example, there are two cameras to acquire each emission channel from the sample at the very same time and calculate the ratio between these two images. But it is also possible to use a single camera. In this case, the ratio would be calculated every two images received. For those of you who are not familiar with the way INSCOPER controls the microscope, in fact, the full acquisition sequence is run by this device controller independently from the computer. This innovative way of controlling the microscope allows full signal synchronization and removes all software latency, whatever the acquisition sequence. This is particularly relevant for rapid biological phenomena such as calcium flux, to avoid unnecessary exposure in order to reduce photobleaching or to be sure to have perfect synchronization between sample illumination and camera exposure. The software interface offers specific lookup tables and background subtraction feature, so the biologist can obtain processed images directly during the acquisition in real time to check the quality of his or her acquisition. The user can also interact with live image to add, remove, or edit regions of interest. Changes in the regions of interest are automatically updated in the graph, both with the raw data and the ratio data displays. The liveRATIO is a complete software and hardware package not limited to ratiometric imaging applications. In fact, this is a standalone image acquisition solution that controls the entire microscopy system. Users benefit from a modern software environment to easily set up their multidimensional acquisition sequences. It can be installed on a shared microscope to address various imaging needs. This is, of course, an adequate solution to upgrade or renew an aging microscope, but it is also well fitted to build and customize a new system with ratiometric capabilities. So now it's time to hear a few words from Joe Whetstone, CoolLED.
Hello, this is Joe Whetstone, the Field Sales Manager for CoolLED, looking after Europe, Middle East and Africa. I am delighted to be here to speak to you regarding our collaboration with INSCOPER using our pE-800 fura illumination system at the Micro PI Cell Imaging Centre in Nantes. At CoolLED we offer a wide range of illumination systems, from the single wavelength pE-100 and PT-100 series through to the broad spectrum pE-300 series and specialist pE-340 fura. There are also multiple controllable LED options such as the pE-4000 and our new flagship pE-800 series, which includes the pE-800 fura that we will be focusing on in this webinar. Our illumination systems are compatible with most microscopes using adapters that we have developed. The pE-800 fura has 8 individually controllable channels, liquid light guide delivery, software, digital and analog control, including market-leading less than 7 microseconds TTL triggering. The inline 8-position filter holder removes the need for external filter wheels. Multiple parameters can be tightly controlled through many popular imaging software programs, and as you will see, it works particularly well with the INSCOPER solution. Our product offers many parameters to control, and the INSCOPER solution provides a seamless interface. It's a perfect match. The pE-800 fura has broad spectral coverage from 340 to 635 nanometers, tailored for calcium imaging, as well as fluorophores for everyday fluorescence, ranging from fura 2 to Psi-5, making it the most comprehensive calcium imaging system available. We introduced the pE-800 fura following feedback received by the imaging community after we launched the pE-800 for general live cell fluorescence. By swapping a few LEDs to enable fura 2 imaging, we are able to provide the imaging community with a highly flexible light source that can not only be used for ratiometric calcium imaging, but also for when their research demands other fluorescence applications. LED wavelengths are broader than lasers and can be optimized with careful consideration of optical filters. In the tables here, you can see some popular fluorophores and their corresponding pE-800 fura LED. Tight hardware synchronization minimizes exposure of living samples, protecting against photobleaching and phototoxicity. Sensitive samples are further protected by balancing irradiance to the lowest levels whilst maintaining image quality, with fine control in 0.1 increments from 0 to 2% and 1% increments from 2 to 100%. This will help you to achieve lifelike cell behavior for accurate results or to extend time-lapse studies. Combine all this with the easy-to-use INSCOPER algorithm that removes the background in the images in real time, and you have the perfect solution, which you will see demonstrated. Thank you for joining us, and I hope that you enjoy the rest of the demo. If you want to find out more about CoolLED products, please do get in touch.
Thank you for this presentation, Joe. Now we move to the microscope for the demo with Julien.
So now let's move to the online demonstration. So I'm very happy today to present you the experiments we performed with the INSCOPER liveRATIO and the new light source from coolLED. This new light source is dedicated to ratiometric imaging and is named the pE-800 fura. For this demonstration, I will show you the activation of gamma delta T cells following phosphoantigen stimulation. For that, we label these cells with fura2 and monitor the calcium flux as an indicator of their activation. The fura2 is a fluorescent probe often used for ratiometric imaging of calcium. By switching the excitation light from 340 to 380 nanometers, it is easy to differentiate the calcium bound to calcium-free probe. To have access to such cells, we collaborated with an academic microscopy facility core in Nantes, in the west of France. We installed the INSCOPER liveRATIO on the Leica video microscope and integrated the new light source of coolLED. All experiments were recorded some weeks ago, and I'll present you today the results we had. So first, let's open the INSCOPER liveRATIO software. So we will make today a new project and name it liveRATIO. Okay, now the software is open, we are ready to work. So the INSCOPER user journey is organized into three main steps: configuration, acquisition, and visualization. So here we are in the configuration window. Here, in the left part of the window, we have a large space dedicated to live visualization of our cells. We can also interact with camera settings here, such as exposure time, for example. We also have access to other more tricky settings by clicking on this advanced button. In the right part of the window, we are able to interact with all motorized elements of the microscope. For example, we can here change the objectives or move the XY stage using this virtual joystick. We can also pilot any light source, including the new coolLED, light source from coolLED. As you can see here, the new light source can be piloted by the INSCOPER liveRATIO. So we can switch on, switch off each wavelength, and by clicking on this button. And we can also control the light intensity and adapt it to our samples. So today we are mainly interested in these two wavelengths. For fura2 excitation. A rapid combination of this excitation light will allow the detection of calcium-bound and calcium-free fura2 probes. With the INSCOPER liveRATIO, we can manually create channels, including the choice of the wavelength, the dichroic cube, and filters. So this combination can be saved and reused at any time. So, for example, let's create a channel. So we will switch on this wavelength, and set, for example, 10% of intensity. Okay, and when now I click on live, as you can see, we have access to the live image of all cells. Okay. When a channel has already been done manually, it can be saved and recalled at any time. So let's recall, for example, the 380 nanometer channel. So where it is here, so I click in this button, and as you can see, settings are reloaded. So perfect. There are also some tools that can be useful for users. For example, there is the contrast here that can be modified. So now we can move to the second step of the user journey. It is acquisition. So as you can see, the INSCOPER software allows users to perform multi-dimension imaging while ratiometric protocols are running. So we can realize time-lapse, multi-position, tiling, Z-stacks, or multi-channel imaging. For our ratiometric experiments, we need to set up a time lapse. So let's here set 90 position, for example, and an interval of 10 seconds. So okay, I can confirm. I do not need any multi-position or this stack dimension, but I need multi-channel. So we need to select the two channels we need. So let's reload them, this one and this one. I can confirm. Now the multidimensional acquisition is fully configured. We just have to select the data processing for ratiometric imaging. So this option is here. And we have some parameters to edit. So as you can see, the first step is to select the ratio we want. So it is not this one, it is this one we are interested in. And we can also select a threshold that will be useful to remove the background of our images. So for that, we need to create an ROI that can, without any signal, that will be used for our acquisition. So let's make it. So let's select an area without signal. So for example, this one. Okay. So I click here to apply this ROI and I click on confirmed. So now our acquisition is ready. So let's start the acquisition. As I told you, this sequence has been realized some weeks ago, so to avoid a 10-minute waiting during the acquisition, I will show you this acquisition in fast forward. So now the acquisition is running, so we can apply the LUT special for ratiometric. As you can see here, blue means low calcium, while red means high calcium concentration. In the middle of our window, we have access to live monitoring. So now we see these threshold measurements. So let's select now an area with a tail. So here you can see in the solid line there is the 340. There is a 340 nanometers fluorescent intensity, while in the dashed line correspond to the 380 nanometers fluorescence. And here in the second graphics, you can see the rationalized data. So here we have an increase of the ratio that corresponds to an increase of the 340 nanometers fluorescence, while there is a decrease of the 380 nanometers fluorescence. We then choose to add some phosphoantigens to activate our lymphocytes. And as you can see here in the fast forward acquisition, there is progressively an increase of the ratio in several cells. So now the acquisition is finished. We have access to all our images. As you can see here, we can also, with this play button, have a look of the whole sequence. Okay. And if we want, we can switch to the graphic view of our image. So let's remove the threshold one, okay, and we can add as a ROI as we want. So for example, I add a new one, and as you can see, there is here a new ROI that can be visualized here. All this data can be saved in a .csv file, and obviously all the images are saved and can be exported in video or hyperstacks. So the online demonstration is now finished, so I hope I could give you all the information you needed. So do not hesitate to contact us if you want to have more information or if you want to have a personalized demonstration.